Okay, Algebra 2A cohorts, both A and B. This is Mrs. Adams, and we are going to be going over our first quiz review, okay? Our quiz will cover sections 1-1 to 1-4. You should have the actual practice quiz in front of you as we're going through this review. If you have questions, please make sure you post your questions in Schoology. Some of you guys will be taking this quiz remote, while others of you will be taking it in class. So we want to make sure we just do the review, okay? So our first question deals with algebraic expressions. So here are some keywords that you might need to go over as we begin to prepare for this quiz, okay? So when dealing with algebraic expressions, some keywords that we're going to use are dealing with total, sum, or all together. We usually add. When we talk about difference, less than, or much more, we're going to subtract. When we talk about product, each, or times, we're going to multiply. And then usually when you see something that says split evenly or quotient, we're going to divide. So if you're looking at your first question, it says write an algebraic expression to represent the number of letters Isabel wrote. Isabel wrote 10 letters to friends each month for X months in a row. So my keyword in number 1 is going to be each. So she wrote 10 letters each month. So my keyword is each. So I'm going to represent that as 10x. Okay, number 2 wants us to evaluate. And when we evaluate, we are just substituting variables with actual numbers. So I'm going to put substituting. All right, and so when we evaluate, we are always given what each variable would represent. So it says evaluate G plus S when G is equal to 9 and S is equal to 3. So actually we're just going to solve this by adding 9 plus 3 because we are substituting our variables. So 9 plus 3 is 12. So that would be your answer for that one whenever they want us to evaluate. You are just substituting. The next one, number 3, is another evaluation problem. So we have 6 plus x minus 9 times 7. They tell us that x is equal to 7. So what we're going to do is plug everything in. So we have 6 plus 7 minus 9 times 7. So we are going to look at order of operations first. And if we remember PEMDAS, I have to do multiplication first. So what we're going to do is 9 times 7, which is 63. And as you see, I'm going to bring everything else back down. When I only have addition and subtraction, I solve from left to right. So please make sure you are following order of operations. And if I do that, I have 6 plus 7, which is 13, minus 63. My answer is negative 50. So make sure you use order of operations when solving these problems. Okay, for number 4, we are going to be combining like terms. All right, like terms means they have the same variable with the same exponent, and then I can combine them. So for example, number 4 in our review, we have s squared minus 3s plus t plus 5s squared. All right, remember when we can combine variables and exponents that are exactly the same. So looking at number 4, I would combine s squared and 5s squared. All right, so 1s squared plus 5s squared gives me 6s squared. Those are the only two that I can combine. So I'm just going to write what I see left. So we have 6s squared minus 3s plus t. And that's it. That's all I have. There's nothing else to do. Okay? Okay. Now number 5 can be a little tricky because of the way it's worded. So why don't we go through this one? All right. Murphy's motorcycle gets 55 miles per gallon of gas on the highway and 45 miles per gallon of gas in the city. The motorcycle holds 8 gallons of gas. We have to write and simplify an expression for the total number of miles Murphy can travel if he has a full tank of gas. After that, we have to then find the number of miles Murphy can travel if he uses 2 gallons on the highway and the rest in the city. All right, so that was cumbersome. So let's write down what we know. All right, so for number 5, this is another combining like terms lesson. So we know Murphy can go 55 miles per gallon on the highway. We know that he can go 45 miles per gallon in the city. And we know that his motorcycle holds 8 gallons of gas. So why don't we try to figure this one out? Well, I know that the highway can hold 55 gallons. Okay. Plus the 45 in the city, but we also have to take into account that his motorcycle holds 8 gallons of gas minus the number of miles that he's driven. That's our expression. So from here, we're going to get ready to simplify and combine some like terms. So it looks like I can take the 45 and distribute it to both the 8 and the x. So now I have 55x plus 360 minus 45x. And just like in number 4, when we combine our like terms, I'm going to combine my negative 45 and my 55, and that is going to give me 10x plus 360. And that's my expression. So the second part of the question says, find the number of miles Murphy can travel if he uses 2 gallons of gas. Well, our x represents the gallons of gas. So we know that's going to represent 2. So I am going to do 10 times the 2 plus the 360. That is going to give me 380 miles. All right, if you need to go back through that one, just, rewind the video. but that is what's going to help you guys out with number 5. All right, number 6. They want us to order from least to greatest. Okay, so we have 4, we have -1/8, we have square root of 8, we have 0.1721, and we have 3 pi. Okay, before we order these numbers from least to greatest, I suggest that you change every number that you can to a decimal. All right, because that's going to help us order these numbers. So for -1/8, changing that to a decimal would be -0.125. The square root of 8, if we round it to the nearest hundredth, we get 2.83. And 3 pi, also, if we round it to the nearest hundredth, is 9.42. All right. So to put these numbers in order from least to greatest, we always look for the negatives because that's going to be our first number. So our first number is going to be -1/8. Okay. The next smallest number would be 0.1721. The next smallest number would be the square root of 8. The next number would be 4, and then 3 pi. All right, that's all we have to do for number 6 is put numbers in order from least to greatest. If you want, you can use a number line. That might make it a little bit more concrete for you so that you could see where all of the numbers belong on the number line. But I also like changing them to decimals because it makes me think of money. And we all know how to counter money. For number 7, we are going to use interval notation to represent this inequality. So our inequality is -3 is less than or equal to x, which is less than 6. So for interval notation, I'm going to give you the notes for it because we don't know which type of question we'll have on our quiz. So for interval notation, we are using either parentheses or brackets. So we use parentheses if we have either a greater than sign or a less than sign with an open circle on our number line. We use brackets if we have a greater than or equal to, less than or equal to, or a closed circle on our number line. All right, so we have to remember parentheses or brackets. And so we use, for an inequality, we use our symbols. So I'm going to circle this part, and I'm going to circle this part. All right. When you write numbers in interval notation, you always start with your low end and your high end. So my low number is -3. My high number is 6. Now I'm going to look at my inequality sign to determine if I have a bracket or a parenthesis. Well, you can look at -3 and see that's associated with the less than or equal to sign. So for -3, that is a bracket. If I look at 6, that is just the less than symbol. And if I look at my notes, the less than symbol is with the parenthesis. So if I am taking these notes, I would write down both intervals or both type of what we call interval emojis from Mr. Haberak. And then we can determine whether we are using a bracket or a parenthesis. For number 8, we have been given a number line, and we are to write this number line in set builder notation. Okay, so set builder notation is kind of easy because I'm just combining the set builder notation and an inequality together. So for set builder, we always start off with the braces and we write X line, which means that's X such that. And now we're going to look at our inequality. It looks like my numbers on this inequality are between -2 and 2. That's what that shaded region represents. All numbers between -2 and +2. So my low end is -2. Because there is a closed circle at -2, I have less than or equal to X. And because there's an open circle at +2, it's just going to be less than 2. And then I'm going to close it with my braces. So there's my inequality for this number line in set builder notation. Remember, always pay close attention to your open circle and your closed circle. For number 9, we are asked to find the additive and multiplicative inverse of -4/11. So what I would do if I were you taking notes, I would write what the inverses are. So for additive means just the opposite. So opposite sign. Multiplicative means the reciprocal. Or it's just the flip of the number. Okay, so if I have been given -4/11, the additive is the opposite, which is just a +4/11. And the multiplicative is just the flip. But remember, we're only flipping the original number, so which is going to be -11/4. We don't change the sign for the multiplicative. We're only flipping the original. Okay, for number 10, we are to figure out or identify the correct property. So for your quiz, we're not for sure which property you're going to have, so I suggest that you write all of the properties down that you may need. So the 3 properties that we really use are commutative, so the commutative property, we're going to use the notes for this one. It says the order of the numbers change. It's your commute. It's your commuting from home to school or from school to home. All right, that's how we commute. The next one is associative. With the associative property, the order stays the same and the grouping changes. And the last one is distributive property. You guys use this one a lot, and that's when we're multiplying a number by a product or a sum. I'm sorry, a sum or a difference. Okay. So for your review, we are given 12 plus 8 equals 8 plus 12. So do you see, this one would be commutative. All right, because the order of the numbers changed. There was no grouping that changed, only the order. So we go from 12 plus 8, and then it's equal 8 plus 12, but the sum remains the same. So that's the commutative property. Okay, number 11 wants us to use mental math to find 11% tax on a backpack that costs $25. Now, it says use mental math, but I know my students, I know a lot of you are just going to pick up that calculator. So because you are going to pick up that calculator, the first thing I want to show you is how to convert a percent to a decimal. And you do that simply by dividing the percent by 100 or moving your decimal 2 places to the left. So I'm going to say 11 divided by 100 equals 0.11. All right. And it says 11% of the cost of the backpack. All right. So we're going to take our 0.11 and we're going to multiply that by the cost of the backpack, which is $25, and we're going to get 2.75. So the tax of the backpack is $2.75. So remember, when you're using this one, if you're going to use your calculator, if you're going to cheat, make sure you convert your percent to a decimal first and then multiply it by the cost. Okay, for number 12, we have to simplify the expression. Okay, so what I would tell you is to use your calculator. Okay, I would say for you to use your calculator. But because I don't have my graphing calculator with me, I'm going to show you how to do this by hand. So first, what I would do is simplify the inside of the radical first. All right, sometimes it makes it a little bit easier. So if I was to simplify 75 over 192, I would get 25 over 64 because both are divisible by 3. So now once they simplified, I could see that both my numerator and denominator are perfect squares. So the square root of 25 is just 5, and the square root of 64 is 8. So my answer is 5 over 8. But I could put that in one step in my calculator, and it would do that for me. Okay, so if you don't have a graphing calculator and you're taking this quiz remote at home, make sure you simplify first, simplify the inside of the radical, and then take the square root. Almost there, we're almost done. So number 13, we are to add like radicals. So we're going to be combining like terms. It's pretty much the same format. So if I have 19 square roots of 7 plus 5 square roots of 7, okay? Because my radicals are alike, I can add the numbers on the outside. Okay, so this is the exact same as if you were to have 19x plus 5x, that would give you 24x. The variable did not change, it stays the same. Likewise for when we're adding like radicals together. So I have 19 square roots of 7 plus 5 square roots of 7 is going to give me 24 square roots of 7. I didn't do anything with my radicals. I just looked to see if they were alike. If they were alike, I can add the numbers on the outside or subtract the numbers on the outside together. Okay, hopefully that makes sense. If you have a question, remember to post it on our Schoology discussion board. Okay, our last problem is number 14, where I'm supposed to simplify the square root. So we have the square root of 2 divided by the square root of 13. Well, first thing I'm going to do is try to see if I can combine the radicals and see if I can simplify. But because I cannot do that, I must rationalize the denominator. All right, here's my hint. No radicals in the denominator. Okay, I can never have radicals in the denominator, so I have to get rid of that. And what we're going to do to get rid of that is I'm going to multiply my numerator and my denominator by what's in the denominator. All right, I know that sounds a little confusing, so I'm just going to show you. So if I have square roots of 2 in my numerator over the square root of 13, I'm going to multiply the top and the bottom by the square root of 13. All right, I'm doing this kind of the long way out, okay? So when I do that, I have square roots of 26 in the top, or my numerator, over the square root of 169 in the denominator. Well, my top, I can't simplify that anymore. That has to stay the same. There's no perfect square that can go into 26. So that stays as the square root of 26. However, 169 is a perfect square, so I can take the square root of 169, which gives me 13. This is my final answer. I can do nothing else from there. All right, remember, no radicals of any kind or square roots in the denominator. All right, well, this was our last question for our quiz review. I hope that you took really good notes. If you have any questions, again, post them in our Schoology discussion page, and Mr. Habrack or I will try to go over it with you as soon as possible. Please do it before the quiz. We will not be going over a review when you are assigned to take the quiz. So any questions that you may have, if you are taking this quiz remotely, will have to be prior to the quiz. I will also post these notes on our Schoology website as well for you. All right, take care. Hope you guys do great on your first quiz.